Okay, hey class, welcome back. Module 9, we're going to get started with. There's a lot to cover in this first lesson for Module 9. So you might want to get a sheet of paper out to take notes or whatnot. It's up to you. I also was going to show you too. You can, if you are going to your assignment page, you'll have the recording here. Just a reminder on all of these, you can have, if you want to make a copy of any of the slides that we're using in the presentation, click on here, make a copy. You can print that out, and then you have all the examples that I do go through in the recordings. Also in this recording, I'm going to go through a little GeoGebra applet using the Pythagorean Theorem. And so if you would like to, I highly recommend it. Click there and you'll have a little applet there that will also go through that GeoGebra Pythagorean Theorem interactive. So back to those slides, we are going to be going over Module 9, right triangles and trigonometry. Just a quick note, we are going to skip 9.2 and 9.3, so don't worry about those. Special right triangles and similar right triangles, we cover the topics that are in those in the other lessons, and they are not in your standards, the new state standards. So we're skip them. 9.1, the Pythagorean Theorem. Our learning target today, understand and apply the Pythagorean Theorem. Our success criteria, I can list common Pythagorean triples. I can find missing lengths of sides of triangles. I can classify a triangle as acute, right, obtuse, given just its side lengths. So I did bring my good buddy, my best buddy, Wrigley here to teach you part of this because this is probably the most important part of the lesson. And I figure if you hear it from Wrigley, maybe you'll remember it. So here you go with Wrigley.
It's Pythagorean theorem. It only works for right triangles. Remember that.
You guys remember that? If you want, I can just play it one more time.
It's Pythagorean theorem. It only works for right triangles. Remember that.
So Pythagorean theorem only works for right triangles. You guys can remember that, right?
It's Pythagorean theorem.
I didn't mean to play it again.
Works.
Sorry. And so a right triangle, let's just go over really quickly like what it is as a reminder. So I'm going to go ahead and just annotate a right triangle here. Let's use blue. I like blue. I feel like that one's a clear one to see. So right triangle, what it means to be a right triangle is that it has one angle that is 90 degrees. And so ooh, that is a beautiful right triangle. The sides should be straight, but so one angle should be 90 degrees. And so the notation, if it's 90, it will have a box. Sometimes it will have a red box. It doesn't matter really, as long as it has that box. That box notates that that angle is 90 degrees. It doesn't always have to have the box. It could just say it's 90 degrees. But in order to do Pythagorean theorem, we have to have a triangle that is 90 degrees, a right triangle. Okay, the other key things about this, you have three sides of your triangle. The other two angles, three angles, three sides. The other two angles, they need to add up to 90 because the sum of your angles add up to 180. Another key word is this side that's across the 90. Okay, that side there is what's called your hypotenuse. Okay, that is the longest leg of a right triangle. And actually, I'm going to call it not longest leg, I'm going to call it longest side. Longest side of a right triangle. So you can only have a hypotenuse if you have a right triangle. The hypotenuse is the one across from 90. It's the longest one. This is really, really important when you do Pythagorean theorem because the hypotenuse is always your C. It's that part that is across the 90, always the longest. The other two, we can just call them legs, leg and leg. And key other things when you're naming triangles, you'll notice that angles are generally labeled with capital letters. So if this is angle A right here, that stands for that angle, that opening there. This is angle B here, that stands for that opening there. And this is angle C. And how they name the sides, they're in association with the angle. So side C would be the side across from angle C. So angle C opens up, it's across from side C, and we call it little c. Side B would be across from side B. Side A would be across from side A. And so you can name sides in a couple different ways. We can name them by those little letters. You can say, okay, side C is our hypotenuse, or we can call it side AB, capital AB, using just segment notation. So lots of things to kind of remember here. This notation sometimes like to change in geometry, so it is really important to understand when we use those capital letters compared to using the lowercase letters, and also that C is generally used for the hypotenuse. All right, again, feel free to take a screenshot of that, take notes, and also make sure you're either using those slides or following along in your textbook, because this stuff is all in your textbook. And next up, we have our theorem, Pythagorean theorem. It says, in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the sides. So C squared equals A squared plus B squared. Really though, I mean, a lot of times you'll see it in a different ordering. A lot of times you'll see it as A squared plus B squared equals C squared. That's the same thing, just written in another order. The key thing though is that C, the longest side of your triangle, has to be the hypotenuse. It has to be the one that is equal to, okay? Otherwise, you're not going to get it correct. And again, here's that little GeoGebra applet here. I didn't put a link into these slides. Remember, I put it in. If you click, just a really quick reminder here, that if you click, again, right here, click there, please, and you will see that interactive that for that Pythagorean theorem. All right, let's continue on here. Next slide. All right, so we do have a few key tricks to remembering Pythagorean theorem. A lot of times we don't even have to use A squared plus B squared equals C squared. You can use what's called a Pythagorean triple. That's a set of 3 positive integers, A, B, and C, that will always satisfy that Pythagorean theorem. So one set of Pythagorean triples is the 3, 4, 5 triple. So what that means is if you have a triangle and you know, for instance, that one side is 3, another side is 4, you can, oh, what did just happened? Oh, I don't know what just happened, sorry. You can, without even doing A squared plus B squared equals C squared, we know that that's a Pythagorean triple, so the third side is 5. That's what happened. I clicked my pen and so it didn't write. The third side is 5. And if we do a little mental math here, we can see, okay, 3 squared plus 4 squared, 9 plus 16 is 25. Square root of 25 is 5, so that one works. These are just multiplies of the Pythagorean triple. We double these numbers. We triple these numbers. So any multiple of those numbers will also work. So for instance, you have a triangle that looks like this. Maybe we know this side is 15. This side is 12. What would the other side be? It would have to be 9. Because it's the Pythagorean triple. So if you want, maybe a good idea to take a screenshot of these, the other Pythagorean triples, 5, 12, 13, 8, 15, 17, 7, 24, 25. There's actually quite a bit more of them if you want to research that on the internet. But that's just the way I do those a lot, especially when I'm creating problems. I use the Pythagorean triples when I'm creating problems. And so you will see those pop up quite often. So it is a good idea to at least get those in your memory just a bit. And next up, all right, we're going to do a couple examples here. So we're going to find the value of x, and then we're going to decide, is this a Pythagorean triple or not? So first off, to find the value of x, we're going to use our Pythagorean theorem. So a squared plus b squared equals c squared. Our c is that hypotenuse. So our c in this case is our x, which is the longest one, that crossed from 90. The other two don't matter the order. So I'm just going to plug those in as 4 squared plus 6 squared equals x squared. 4 squared is 16. 6 squared is 36. And that's going to equal our x squared. What is 16 plus 36? Again, totally fine to use a calculator. So let's do 16 plus 36, that's 52, equals x squared. What do we do from here in order to find x? Well, we take the square root of both sides. So we're going to find the square root of 52. Square root 52, hit that square root button on your calculator. It's approximately 7.2. So approximately 7.2. If we want the reduced radical form of this, just a reminder, and maybe it's been a while, but we're going to reduce that square root of 52. We're going to find that perfect square that divides evenly into 52. So let's see if we can find that. 4. So 52 is the same thing as 4 times 13. Just doing a little mental math here. 4 is that perfect square. We can break this out as the same as square root of 4 times square root of 13. Square root of 4 is 2, so we can write that as 2 root 13. So that is like non-rounded exact answer. So if you ever see a problem that wants the exact answer, then that would be that. Otherwise, feel free to put in that decimal form, 7.2. Is this a Pythagorean theorem? No, it's not, because it was a rounded one. If it was a Pythagorean triple, then it wouldn't be a decimal. You would have an exact number when you did that square root. So is it a Pythagorean theorem? No, it's not. All right, let's try some more. That says 7.2 if you needed to clear that up a little bit. All right, what do we have next? We're going to try another one, example 2. Tell whether the sides form a Pythagorean triple. This one I'm actually just going to think maybe. Remember the Pythagorean triples? We have 5 as our c. The other 2, what would they be? Let's go ahead and do a squared plus b squared equals c squared. Our c is that hypotenuse, so our c has to be that longest one across the 90. The other 2 do not matter, so I'm going to plug them in as x squared plus 3 squared equals c squared. Whoops, not c. C was 5 equals 5 squared. So x squared is just x squared, 3 squared is 9, 5 squared is 25. This time we have to do a little more math. We're going to subtract the 9 from both sides. Then we get x squared equals 16. How do we solve for that? Well, we square root both sides. Square root of 16, put that in your calculator. I actually memorized that one. What times what 16? It's 4. So our answer is 4. And I know some of you may be thinking it should be plus or minus 4. Because we're actually talking about the length of a side of something, we don't take the negative answer because there's no side length that would be a -4. So when we're doing Pythagorean theorem, you actually just take the positive. So x is 4. This means that it is a 3, 4, 5 triangle. Was that a Pythagorean triple? Let's go back and check that out just to make sure. Pythagorean triples, 3, 4, 5. It sure was. And so actually I could have just looked at this problem, and if I had those memorized, I could have been like, okay, we've got a 3 and a 5, that one's 4, and I wouldn't have had to do all of this math. So was it a Pythagorean triple? Yes, it certainly was. All right, let's keep moving along here. I think I lost my mouse somehow. Interesting. Oh, there it is. Okay. And next slide. All right, let's try this one. Is it a Pythagorean triple? Let's look. Is there one that's 9 and 15? Let's just look at the list. Ends with 15. No, there wasn't. 9, 12, 15. Yes, there certainly is. That's a Pythagorean triple right there. So 9, 12, 15. Go ahead and do Pythagorean theorem if you want to double check our work, but that should be x is 12. Yes, it was a Pythagorean triple because we would do a squared plus b squared equals c squared. The c is 15 in this case. A and b are x squared plus 9 squared. And then you'd go ahead and finish those off and figure out what x is. But since we knew those Pythagorean triples, it made it quite a bit easier, right? Okay, let's see if we have any more of these types. No, okay. So actually, moving on from there, we're going to use what's called the converse of the Pythagorean theorem, and that's going backwards from the Pythagorean theorem. Converse means you switch the order. So it's really just saying, okay, what if we weren't given the fact that it was a right triangle? What if you just have a triangle listed like this? And they're like, is it right? Well, it would be right if the Pythagorean theorem is true. So you would just use your Pythagorean theorem and say, okay, since Pythagorean theorem worked, since a squared plus b squared does equal c squared, sure thing, it is a right triangle. If it doesn't work, then it's not. It's either obtuse or acute. And we actually have classifications for those as well. But first off, we're just going to go through, is it right or not? And so this is saying, okay, looking at that, I mean, it looks right to me, right? Doesn't it look like this should be a right angle right there? But I don't know, we got to test that out. We can't just assume in math. So we are going to do a squared plus b squared equals c squared. A and b would be 22 plus 14 equals that 26 squared. Sorry, 22 squared. Let's check those out in our calculator. So 22 squared, 484. Plus 14 squared. What's going on downstairs? 196 equals 26 squared. 676. Do those equal each other? 484 plus 196. 484 plus 196 is 680. 680, does that equal 676? Pretty close. It's pretty close to being right, but it's not. They don't equal each other. So the triangle is not a right triangle. So you just want to check that Pythagorean theorem, check it out to see if it works or not. Okay, that's how we do those. Let's see, I don't think, let's skip forward to the next one here. The converse of the Pythagorean theorem is used to determine if a triangle is right. You can use the theorem below to determine if it's acute or obtuse also. So what happens here is if you end up getting the fact that c squared is less than the combination of a squared plus b squared, then it's acute. Okay, if c squared is more than the combination of a squared plus b squared, then it's going to be obtuse. So let's go ahead and do some examples here. Determine whether the segments with lengths 3, 4, and 6 form a triangle. Is it going to be acute, right, or obtuse? And if not, leave the selection. So we have our triangle here. It's 3, 4, and 6. So we draw our triangle. It's obviously not right because the right one's 3, 4, 5. So we know it's not right. We can kind of take that away. But is it going to be acute or obtuse? And so we're going to use Pythagorean theorem. So 3 squared plus 4 squared equals 6 squared. 9 plus 16 equals 36. 9 plus 16 is going to give us 25. So is 25, that's obviously not equal to 36, but what is it? The combination of the a squared plus b squared, the c squared, so this part, a squared plus b squared, is less than the c squared. So the c squared is getting eaten by the alligator. So which one was that where the c squared got eaten by the alligator? That one was c squared's eaten by the alligator. It's an obtuse triangle. So if the c squared is eaten by the alligator, we get obtuse. Oops, needed to mark that, sorry. Obtuse. Draw that. Obtuse. All right, I think we have one more quick example here to do. It's very similar, just making sure we solidify this before you try some on your own. This one is a try on your own, so go ahead and pause that if you need to. Try this on your own and then come back to the recording and see if you're getting the same answer that I am. So this one says determine whether the segments with 2.1, 2.8, and 3.5 form a triangle. So we're going to draw our triangle here. 2.1, 2.8, and 3.5. So we're going to do 2.1 squared plus 2.8 squared plus 3.5, or sorry, equals 3.5 squared. Does it equal that? Not sure. Sorry, I meant equals 3.5 squared. Well, let's test that out. 2.1 squared, we are going to do 2.1 times 2.1, 4.41, plus 2.8 squared, 2.8 times 2.8, 7.84, equals 3.5 squared. 3.5 times 3.5 is 12.25. Well, let's add those up. So 4.41 plus 7.84 is going to give us 12.25. Look at that. So in this case, since left equals right, that means there are equal. So Pythagorean theorem did work. And so it is indeed a right triangle. So again, if a squared plus b squared equals c squared, it is right. If a squared plus b squared and the alligator is eating the c squared, it's obtuse. And if a squared plus b squared is less than c squared, it's going to be acute. So those are how you test them. All right. So that is it for the recording for this lesson. Be sure, though, that you are, let's clear this out. Be sure to check your textbook for 9.1. Remember, you can click on that link, Big Ideas Math. It'll take you to 9.1 if you can, use your hamburger icon or whatnot if you need to. There's more examples in there. There's examples that are worked out in recordings and whatnot. So if you're needing more help, again, make sure you're checking that out and completing that self-assessment. And that's it for now. All right, 9.4, the tangent ratio. Our learning target today is we're going to understand and use the tangent ratio. And our success criteria, I can explain the tangent ratio, I can find tangent ratios, and I can use tangent ratios to solve real life problems. We have a tangent alert here. Tangent is just a word used in trigonometry. Trigonometry, we will go over in a minute here, but it is the study of triangles. And in trigonometry, we have sine, we have cosine, and we have tangent. And today we're going to talk about tangent. It's a tangent ratio. Let's skip that. Using the tangent ratio. So again, as I just said before, a trigonometric ratio is a ratio of the lengths of two sides in a right triangle. So again, we have to have right triangles. All right triangles with a given acute angle are similar by the angle-angle similarity theorem. So we can set up some ratios of those sides, and those trigonomic ratios are constant for any angle measure. The tangent ratio, which is what we're going over today, is a trigonometric ratio for acute angles that involves the lengths of the legs. So we're not involving the hypotenuse today. We are involving the legs. So it's the ratio of the legs of the right triangle. So I'm going to draw a little picture here for us. And do it with my pen. So I'm going to do this with my mouse. Should be fun. Boop, boop, boop. Let's go a little bit. Okay, so if we have ourselves a right triangle here. So again, a right triangle means that one of the angles is 90 degrees. So just a reminder that we have that 90-degree angle here. This side is our hypotenuse. We're just going to call it hyp for abbreviation. The other two sides are our legs. So the trigonomic ratio is a ratio of the two legs. And so the tangent ratio is you're going to pick your angle. And so again, let's just call this is angle A, this is angle B, and this is angle C. And so the key thing here is you have to first decide which angle we are taking the trigonomic ratio of. You cannot pick the angle that is the right angle, okay? So for example, say we were given what the measurement of angle A was. You would use that angle to start with. The tangent ratio, tangent of whatever angle you're given or deciding to use. So tangent, we're going to say tangent of theta. Remember, theta means an unknown angle or an angle measure. Tangent of whatever angle we're given is going to be the ratio of the opposite side over the adjacent side. And you're probably like, what do you mean by that? What is the opposite side and the adjacent side? Well, it's based on what angle you know. So we're not dealing with hypotenuse. We're going to forget about that side. We're going to deal with the two legs. Well, which one's the opposite and which one's the adjacent? Again, it depends which angle we know. So if we know this angle right here, we know the measure of this angle is our theta, then the opposite side to that angle would be the one that you shoot an arrow and you hit. It's the one where that angle, if we have our legs where it opens up, where you connect those toothpicks, okay? That is your opposite side, okay? And then the adjacent, another word for adjacent is next to. So the adjacent is actually one of the legs that we drew. And so I'm going to erase that there. So we have those legs of our angle. It's not the hypotenuse, so it's the other one that's adjacent, the one next to the angle that we know. So this is our adjacent. It's spelled AD, adjacent. It's abbreviation for adjacent. Okay, so again, looking at this, if we know this angle theta right here, the opposite side would be this side. The adjacent side would be this side. The hypotenuse is always going to be the hypotenuse, okay? Opposite and adjacent are totally going to depending on if you know angle A or angle B in this case. Again, you never use angle C. You never use the right angle when you're doing this, okay? Let's see what happens if we, for instance, were given, let's do our eraser. If, whoops, not that one. If maybe we, instead of being given angle A, say we don't know that one, this time we know angle B. So say this is our theta. This is the angle we're given. We know, for instance, we know that it's like 40 degrees or something like that. So this time we're going to use angle B. So the opposite of that angle would be actually, they're going to flip-flop. So this is not our adjacent anymore. This is our opposite. And this is our adjacent. So it definitely just depends for opposite and adjacent which angle we are in reference to. Again, we don't use angle C and we don't use the hypotenuse. You're just given your other two acute angles. And you could, if you're given like angle B, you can definitely find angle A because you know the sum of the angles is 180 or vice versa. If you prefer to just use one of the angles, that's totally fine too. All right, let's go ahead and do a few more of the notes and maybe some example problems. So here's just our trigonometric ratio again. This is assuming we know angle A. So this is the leg opposite angle A. This is the leg adjacent angle A. In this case, our A and our B were kind of flip-flop from the one I drew, which can happen. Generally, angle C is going to be the one across the hypotenuse. That's our right angle. Just because of that Pythagorean theorem, it kind of helps it, but it doesn't have to be. We can name angles anything we want. It says, let triangle ABC be a right triangle with acute angle A. The tangent of angle A, written as tan A, is defined as followed. Tangent A equals the length of the opposite angle, the length of the leg opposite to angle A, over the length of the leg adjacent to angle A. So whatever the length of side BC is over the length of side AC. And then from there, you just do some algebra to solve it. And you're probably like, but I promise as we do a few more problems and some examples together, you'll definitely get a little bit of a better handle on this, hopefully. And if not, book us for help, or again, check out those resources in your textbook as well. All right, let's do an example here first. Example 1. It says find tangent of angle J and tangent of angle K. Write answers a fraction in simplest form and as a decimal rounded to 4 decimal places. So the first thing you want to do, we want to know tangent of angle J. So I'm going to find where angle J is. Angle J is right here. So that's what I'm going to do my tangent to first. And so I'm going to label my sides. I always first label my hypotenuse. Hypotenuse is across from the 90. So this is my hypotenuse. And then according to angle J, I name my opposite and my adjacent. So angle J here, opposite is the one where you make a V and where the endpoints end, and that's where you shoot an arrow from that angle J. That would be your opposite side. So 24 is going to be my side that is opposite angle J, side KL. And the side that's adjacent to angle J, so shares one of the legs of that angle, is the 32, the side that's 32, or side JL. So that's my adjacent. Okay, so the tangent of angle J is going to equal the ratio. Hold on, Wrigley is absolutely eating something. Oh, no, he's not. Reggie, no. Hey, mom, mean mom voice. Tangent of angle J is going to equal always the ratio of the opposite side over the adjacent side. So opposite over adjacent. Let's plug in this stuff. Tangent of angle J is going to equal the opposite side was 24. The adjacent, again, tangent's always opposite over adjacent. 24 over 32. We're going to reduce that. So 8, 16, 24. 8 goes into 24 3 times. 8, 16, 24, 32. 8 goes into 32 4 times. So 3/4 is my fraction. And then if we reduce that to a decimal, you can put 24 over 32 in your calculator, or you can just put 3 over 4. 0.75. Okay. Now we are going to kind of flip-flop that, and we're going to do it in terms of angle K. And so let's color code this here. I'm going to look at angle K. So this time for angle K, this is our hypotenuse still is the 40. Our opposite is actually going to be here because you shoot an arrow, you hit it. This is my opposite. And then this is my adjacent. So again, it depends which angle you are in reference to. All right, so let's just set up that ratio. The tangent of angle angle K is again equal to the ratio. Tangent's always opposite over adjacent. But this time, according to angle K, opposite was that 32 and adjacent was 24. So we can reduce that as 4/3. So it's really just the reciprocal, 4/3. So we've got 4/3, and that is a decimal, 4 divided by 3, 1.33 repeating. So it's just the ratio. This is not solving for anything. This is just kind of getting us set up to be able to solve, just remembering how to find those ratios and whatnot. And again, remember, be sure you can print these problems out if you want by clicking on those slides that are in the assignment for today, or just use some paper or pencil and write them down in your notes, however you wish, whatever helps you the best. All right, let's see what we have next. Example 2. All right, we're going to actually do some solving here. Find the value of x. We want to round our answers to the nearest tenth. So it's 2 decimal places. Actually, 1. Sorry. Woo, it's been a while. Hold on one sec. All right, so kind of the same steps, except for this time we're going to actually solve and find that value of that side x. So your first step, like I said before, is you want to make sure and label your sides. Okay, so step 1, label your sides. And go ahead and do that. So I always like to label my hypotenuse first. So this is my hypotenuse. And then this time it doesn't say, do you want sine, cosine, or tangent of a certain angle? So that's when you go, okay, what angle do I know the measure of? We obviously know the measure of the 90-degree angle, but we don't use that angle in trigonometry. So we know the measure of this angle right here. This is our theta. So that is what we are going to base opposite and adjacent on. So we know the angle 61. Opposite of the angle 61 is this side here that's 22. And adjacent is going to be that other side that shares the leg with it. So that's our adjacent side. Okay. All right, so we know the opposite. We're trying to find the adjacent. And so opposite and adjacent are tangent. So we're gonna go ahead and write that ratio out. So again, just a reminder, the ratio for tangent, it's tangent of an angle, is the ratio of the opposite side to the adjacent side. Okay, so let's just plug all this in here. So what we're trying to find here is the tangent of the angle we know, which is 61 degrees. Tangent of 61 degrees is the ratio of the opposite side to the 61 degrees, that was 22, to the adjacent side of the 61 degrees, which was x. And now we have an equation that we can solve because we actually have one unknown, it's the x. Tan 61 is a number we're going to plug into our calculator. Okay, so how we solve this, we want to solve for that x. This is in our denominator right now. We don't like things in our denominator, so we want to get rid of it. And so how we get rid of it, we are going to, right now it's 22 divided by x. We're going to do the inverse operation. We're going to multiply both sides by that x. Cancels out because x over x is 1. What you do to one side, you must do the other. So now we have times x here. So now what we have is x times the tan of 61 equals 22. And I want you to think of tan 61 not as 61. Tan 61 is a ratio. It's a number in your calculator. Okay. And so in order to now solve for that x, think of it as like 3 times x or x times 7 or something like that. It's a number. You can find what that number is by plugging in your calculator right now. You can type in tan 61 and find that decimal. Or we can do it at the end, which does make things a little bit easier, especially when you're using desmos. So we are going to, in order to get rid of that tan 61, just like if you had 2x equals 6, in order to get rid of that 2, you would divide both sides by 2. Same thing here. In order to get rid of the tan 61, to solve for that x, we're going to divide both sides by tan 61. That cancels out. What you do to one side, you must do to the other. All right, and now is when you have to use a calculator for this, okay? And so I want you all actually to please use Desmos because that way I know you're in the right mode and everything for this. And so 22 divided by tan 61, we're going to use Desmos. So I'm going to show you how to do that. And so here's my new tab. We're doing 22 divided by tan 61. So I'm going to leave that on the screen so don't forget. But it's www.desmos.com. And from here, make sure you're clicking the right calculator. So click on Math Tools and do the scientific calculator. That's the one we're going to be using. Okay, the very key thing here is that you need to make sure we're in degrees because we're doing 61 degrees here. So we need to make sure you're in degrees. So this right here needs to be toggled so the degree shows. You don't ever want it to say rad, even though it sounds pretty cool. It means radians, and that's not the measurement that we're using. We're using degrees. So make sure you're toggled so degree shows. And you can actually see right here, we have sine, cosine, and tangent. If you click through these, there's other functions, inverse, sine, invert. We'll use those later. There's a same sine, cosine, tangent, and whatnot. But Desmos is nice because we can actually just plug this in all at once. What we're trying to find was 22 divided by the tan 61. So you can do 22 divided by tan 61. And there's our answer, 12.194799. I believe it wanted one decimal place. So 12.19 rounds to 12.2. So 12.2. And again, like I said, if you were to just maybe type in, if you just wanted to know what the tan of 61 was back then, you could have done, okay, the tan of 61, 1.80. We got to put that in there divided by it. I don't actually think it's 1.80. Maybe it is, but yes, actually that's about right. And so you could plug that in and solve it then too, but it does alleviate a little rounding errors if you do it all at the end. All right, look at that. It's on my page right there. Approximate value is 12.2 for my X. Nice. All right, we are going to go ahead now. You can take a screenshot of that if you want. It's just how it's done there. I'm going to delete and go to the next problem. So this one, I want you to try this on your own. Give it a pause, at least give it an attempt, and then maybe watch the recording afterwards. Make sure you got it right or catch maybe where you got it wrong. Okay, so our first step is to label our sides. So and again, if you maybe are stuck, like, where do I even start? Label your sides. So we always label the hypotenuse first. So we are going to label my hypotenuse here. Okay. According to the angle we know this 56 angle. So that's my angle. I'm going to label the other side. So 56 across from it is our opposite. And 13 is my adjacent. It's next to it. Tangent of theta is going to be opposite over adjacent. So tangent of 56 is going to be my opposite side to 56 degrees, which is X, over my adjacent side, which was 13. This one's a little bit nicer because the denominator isn't the variable. We do the same sort of steps. We just kind of cut one out. So right now it's X divided by 13. In order to solve for that X, we need to do the opposite operation. So we're going to multiply both sides by that 13 in order to get rid of it. What you do to one side, you must do to the other. So actually what we have here, X equals 13 times the tangent of 56. That's what X is going to equal. And so we can actually just go straight from there and plug that into our Desmos calculator. X equals whatever the 13 times the tangent of 56 is. So let's go ahead and go to my calculator. And again, sorry if the writing's on the board when we're doing this in Desmos. It does make it so I can still see it. So we're going to type that in, 13 times the tangent of 56. 19.27, approximately 19.3. I just want you to see something though, if maybe you accidentally type it in a different order. If you type in tan 56 and you forget to close that parenthesis and you times it by 13, you get something totally different because it takes the tangent of those two things multiplied together. So do make sure you're either closing those parentheses or you're putting the order in correctly. You can also do tangent 13 times, you can type in the word tan, I think, 56. Nope. Nice try, Mrs. Reed. Can't do that. 13 times, you gotta hit the symbol tan 56 because it's an actual ratio button. So 19.3 approximately is our answer. So 19.3 is approximately X. Doop, doop, doop. And we'll go ahead and go back to our slides. And that's our approximation, 19.3. Whatever units those are. And you can kind of make sense on these because you're noticing, okay, it's a little more than 13. It makes sense. If your answer is like 5,462, but like one side's 13, or if your answer is like 0.0007, you might have done something wrong and you might want to check back and see. Generally, a lot of times you don't even mean to toggle that degree radian switch, and it happens. And so that's a big thing that does come up in errors. So it's important to just kind of self-check your problems. It is also good why we have those checks in your problems that you do submit. And yep, that was we have one more. We're going to do this one that's kind of a real world problem. And actually this is probably the most used math in the real world is these trig ratios, because if you want to find the height of something and you only know the angle and one length, you can find anything else. You measure the distance from a lamppost and the angle of elevation from the ground to the top of the lamppost. Find the height of the lamppost. So what we know is this angle of elevation here is 70. We know this distance is 40, but we can't climb that lamppost and see how high it is. We can actually just figure out what that height of that is without even getting any sort of measurement from there. And so again, we're going to follow our steps, same steps as before. First step is to label your sides. Always label your hypotenuse first. My hypotenuse is here just to get it out of the way. Okay, this is the angle we know, the 70. So the side opposite that 70 is this opposite side. And then adjacent would be the 40. And again, if you want, go ahead and try this one on your own. Pause and then double back and check it out. Oh, there we go. I was trying to see what that said. Okay, and so we're going to go ahead and go right into this. We know that the tangent of our angle that we know is the opposite over the adjacent. So tangent of our angle we know, which is 70 degrees, is the ratio of the opposite side, which is our height, but so we're trying to find, over the adjacent side, which is 40. Opposite over adjacent doesn't change. Hey, this one's one of those nice ones again to solve because the variable is on the top, not the bottom. But we're going to go ahead and multiply both sides by 40 in order to solve get h, get it all by itself. What you do to one side, you must do the other. So all we have to do now, plug that in your calculator, 40 times the tangent of 70 in order to get your height. And check that out on your own. Make sure you're doing your calculations correctly before you go ahead and check mine in Desmos. And again, use Desmos. Don't use your phone. Don't use a little calculator. Desmos is an amazing free scientific calculator for y'all to use. So we're doing 40 times the tangent of 70. And our answer is approximately 109.89. So 109.9. So 109.9 is our height. What are the units? I'm going to have to go back to our problem. Our units were inches. So 109.9 inches is our answer. So 109.9. I know these problems are tricky. Please make sure if you're not getting these right off the bat, don't attempt your quiz right away. We are probably going to work on this together. Also, just a reminder, it is very important that you are using your resources, okay? These recordings are great, but you have your Big Ideas Math textbook that you can click on. So click that tab. Go to that 2.4 assignment. I'm actually going to show you right here. Maybe, yes, I think well, let's see if we can get into that test student today. Might have logged out. Yes. Okay. So anyways, but when you go to, let's go back to my other student. So when you are in an assignment, just a reminder, this Big Ideas Math tab right here, that will take you to your textbook. Make sure you scroll and find that 2.1. You can use the dynamic text or just the kind of basic vanilla text. And if you need help finding your textbook at all, please let me know because it is a very, very valuable resource. And that is all. Thanks for watching and learning about trigonometry. All right, 9.5, the sine and cosine ratios. Woo-hoo. We've already learned tangents, so let's get into sine and cosine. Learning target today, understand and use the sine and cosine ratios. Our success criteria is I can explain the sine and cosine ratios, I can find sine and cosine ratios, and I can do some real world problems. So the sine and cosine ratios are trigonometric ratios for acute angles that involve the lengths of the leg and the hypotenuse of our right triangle. So remember, trig just involved, trig with tangent just involved the two legs. We did not involve the hypotenuse. Well, we are going to bring that hypotenuse in today, and we are going to set up some ratios involving it. So the two ratios that involve the hypotenuse are the sine and the cosine ratios. The sine ratio is the length of the opposite side over the hypotenuse. In this case, if we're talking about the sine of angle A, the opposite side would be side BC, hypotenuse BA. Cosine of angle A is the length of the adjacent side over the hypotenuse. And don't worry, we'll have some tricks to remember these ratios as long as you can also use screenshots in your textbook and your notes. So, and then we will do a little bit of complementary angles. Just a reminder, complementary angles are two angles that add up to 90 degrees. And so if you want to take a little screenshot of this one, it's a reminder that the sine of an angle is going to equal what's the complement of the cosine of that same angle. So if you're doing the sine of angle A, it's going to equal the cosine of angle B, the complement of that. So first off, we're going to do a little remembering. Let's remember how to label our triangle, because that is the key thing to starting this process. So step one, we have our right angle. We find that. Eyeballs all go to that right angle. And then you're trying to, what angle do we want to find the measure of? We're going to call that our viewpoint. Okay, so either the angle you're given or the angle you want to find, that is our theta, that is our viewpoint. That's where we get our binoculars out. And we're like, okay, that's where we're going to look things from. First thing you always want to do then is you have your three angle measures, A, B, and C. We have our three sides, side A, B, and C. Opposite of that angle, in this case, is going to be side A. Adjacent of that angle, we know angle A is side B. And then always that hypotenuse doesn't ever change. It's always the one across from the right angle. I always usually say label that hypotenuse first too. And just a reminder, tangent was the ratio of the opposite over the adjacent. Sine is the ratio of opposite over hypotenuse, and cosine is ratio of adjacent over hypotenuse. There's actually a way we can remember this. It is called SOHCAHTOA. Did that next slide. So SOHCAHTOA. Sine is the opposite of hypotenuse. Cosine is the adjacent over hypotenuse. TOA, tangent, is opposite over adjacent. It just takes the first letters of each word. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. SOHCAHTOA. So we will use that when we're doing these to determine, are we going to use sine, cosine, or tangent? You'll hear me say it quite often. SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. Continuing on with our trig tips, just a little visual here too. There's our viewpoint there. There's our opposite. There's our hypotenuse. There's our adjacent according to this angle here. So sine is opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. So step one, always label your sides. Always say label your hypotenuse first, then your opposite, then your adjacent. Step two, determine which trig ratio you're going to use. Are we going to use sine, cosine, or are we going to use tangent? And that is really just dependent on what we know. Okay, eliminate the things we don't care about. Look at the angle you know. Do you know an opposite side? Do you know a hypotenuse? Do you know an adjacent side? What are you trying to find? Okay, create your equation then. Once you decide, are we using sine, cosine, or tangent? Write it down. Plug in and solve for the unknown. Be sure and use your calculator. I definitely say use Desmos because then you're making sure you're in degrees, not radians. Little side tip here also, as you're watching this, if you send either me or Miss Kazmierski an email saying I love trig, but not as much as Wrigley, then we will give you 5 bonus points on this assignment. And here's Holland. If you want to see my daughter, she's sitting next to me because I'm actually recording this over break. She loves trig. Okay. So use your calculator. What's trig? You'll learn someday. If the unknown is on the top, the numerator, this is the easy one. You just multiply both sides by that denominator, plug in your calculator and solve. But if the unknown is on that denominator, you're going to have to multiply both sides by that unknown, then divide and then solve. So a little bit harder. All right, so starting off, just a quick one here. Which of the following equations is correct? Which one would we use? And so the first one, sine is opposite over hypotenuse. So our first step, label the triangles, pick the trig ratio, write down the formula. So according to this angle right here, this angle of 25 degrees, our opposite is the 6, and our hypotenuse we do not know. So is sine 25 opposite over hypotenuse 6 over x? No. What about sine 25? No, x over 6. No. How about tangent? Tangent is opposite over adjacent. Tangent of 25 would be opposite over adjacent. 6 over x. Yes. That one worked perfectly. Tangent 25 would not be that one. So that is just setting up your equation. Before we solve it, we would set up this equation. We would multiply both sides by x and then solve it. Find sine, cosine, and tangent, find sine D, sine F, cosine D, and cosine F. Write each answer as a fraction and as a decimal rounded to 4 decimal places. Whoops. All right, so first thing we want to do, let's first do sine of angle D. And so we are going to find angle D. Angle D is right here. We're going to label our sides. So this is my hypotenuse because it's across from the 90. According to angle D, this side 7 is my opposite. It's opposite of angle D. And then 24 would then be our adjacent. These are our labels, anything that is working with angle D. So this will be what we'll use for sine of D and cosine of D. Sine of angle D then, sine, remember sine is the ratio, SOHCAHTOA, opposite over hypotenuse. So sine ratio is the ratio of the opposite, which is 7 over the hypotenuse, which is 25. So the sine ratio, 7 over 25. I'm going to put these in the calculator later. Yeah, actually, we're not going to worry about the calculator part. 7 over 25. And then I'm going to flip, that's to sine of angle D. Sorry, I should have put that D in there. Let's go ahead and do cosine of angle D next. We'll skip the sine of F because we're working on angle D. Cosine of angle D. Cosine is the ratio of adjacent over hypotenuse. Adjacent is the 24. Hypotenuse was 25. That one's 24 over 25. Since we are still, we've got that was not the right spot, was it, that I put it in? That was what I did wrong. That was cosine of angle D, sorry. 24 over 25. Okay, now we're going to talk about angle F. So I'm going to use a different color. I'm going to delete some stuff here. Let's get my eraser out. So now working with angle F. So looking at angle F here, our hypotenuse is still the 25, but this time my opposite of angle F is the 24, side that's 24 length, and adjacent of angle F is the side that's 7. So the sine of angle F.
Are you talking to someone?
I'm recording. Thanks, Hetty. That's my other son. All home. Sine of angle F. Sine is opposite over hypotenuse. So the opposite in this case is 24. Hypotenuse is 25. Notice that the cosine angle D and the sine of angle F are the same thing. So what do you think is going to be the case for the cosine of angle F?
Wow.
Why do we have, oh, it was used for dinner the other night. Yeah, you can use the butter.
I don't want it.
Yeah, sure. That's fine. Okay. All right. And then we're last but not least, the cosine of F, cosine of angle F. Cosine is adjacent over hypotenuse. So adjacent is 7. And hypotenuse was 25. Again, notice that's the same as the sine of D. And then to find those decimals, if you need to, just put those in your calculator. It's just setting it up. We haven't solved any yet. We're just setting up our equations when we do get to solving these. So let's go ahead and do another example. Right, cosine 23 in terms of sine. So again, that was that one slide that was talking about the complement of each. And so you can do this a couple different ways. So it does help if we draw ourselves just a right triangle, just a generic right triangle here. So we have our 90 degrees. Say this was 23 degrees. We can actually, the reason why the complement is the same is because the complement is the measure of the other angle. And so because all those angle measures need to add up to 180, 180 minus that 90, minus that 23. So we're going to do 90 minus 23 degrees. 67 degrees is going to be the other angle. And so the cosine of 23 degrees is going to equal the same thing as the sine of the complement, which is 67 degrees. Okay, and you can double check that. The cosine of the 23 would be adjacent over hypotenuse. Sine of 67 would be opposite over hypotenuse, which in this case would be the opposite. And so you would actually get the same answers. Let's try another one. All right, find the values of mu and t using sine and cosine. Round your answers to the nearest tenth. Oh, and then we have one more example after that. Okay, so we're going to go through those steps. And again, our first steps are to label our sides given what we know. So we are based on this angle right here, this angle 65 degrees. So that is the angle I'm going to label my sides based off of. My 8 is my hypotenuse. The side that says T, that's opposite the 65 degrees. So that is my opposite. And then we have our last but not least, our U here would be our adjacent. Then we're going to pick which trig ratio we are going to use. And so it does help if we write the word SOHCAHTOA out. All right. Well, we are trying to find, in this case, it depends what we're trying to find first. Let's go ahead. We're going to try to find U. U is the adjacent. And what we know is the hypotenuse. So we're going to use the ratio that it involves the adjacent and the hypotenuse. So that's cosine. So cosine is the ratio of the adjacent over the hypotenuse. So let's set that up. Cosine of our angle, 65 degrees, is equal to the ratio of our adjacent, which we said was U, over our hypotenuse, which is 8. I'm going to solve that. So we are going to multiply both sides by 8. Times both sides by 8. This is when we pull up our Desmos and we just do 8 times the cosine 65. That will get us what U is. So let's go ahead and get Desmos out here. 8 times cos 65. We're in degrees. 8. You can do just cos, or you can do times cos 65. It is 3.38. We're rounding to the nearest tenth, so 3.4. Okay, and then we want to find t. We can actually from here, because this we now know is 3.4, you can use Pythagorean theorem if you want. We can also just use, we want to find the opposite, and we know the hypotenuse, so that would be the sine ratio. So we can start over here using sine. Sine of our angle, 65 degrees, equals the ratio of the opposite over the hypotenuse. So that would be t over 8. We're going to multiply both sides by 8, just like before. So this time, though, we're going to put that in our calculator. 8 times the sine of 65. We get a totally different answer. To escape out of here. Okay, there we go. So 8 times sine 65. So let's clear 8 sine 65. 7.25 rounds to 7.3. Approximately t. And again, you could have used Pythagorean theorem. You also could have found this angle right here and used that angle, all sorts of different options, but it should get you to the same thing in the end. And we do have one more example. It's a real life example. So let's give that one a go. So it says you are skiing on a mountain. The angle of depression is 28 degrees. Find the distance from you to the base of the mountain. So we're trying to find this x distance right here. I actually don't like that they labeled it on the inside. This is the same thing, this x here, that distance. And so first step, as always, we label our sides. And so we have our hypotenuse is our x. We have angle that we know is the 28. So this is my opposite of that angle. And then this side over here, which we do not care about, is the adjacent. These ones, actually real life ones, are technically easier than the ones that you have to find more than one thing, because we really just want to find that side x, so one step. So SOHCAHTOA, we're going to decide, are we going to use sine, cosine, or tangent? And in this case, we know the opposite and we're trying to find the hypotenuse. So that means we're going to use sine. Sine of our angle, sorry about that, S. Sine of our angle 28, equals our opposite side, which is 1200, divided by x, our side. This time that variable is in the denominator, so we'd have to do a little bit more work here. Multiply both sides by that x to get rid of it. And so then we have, we're going to have to divide by that sine 28. So x equals 1200 divided by sine 28. Put that in your calculator and we have it. $1,200 divided by sine 28. This is our last problem. 1,200 divided by sine 28. That is, oh goodness, I need to erase some of this to see. 2556.1. 2556.1. Put that in there. 2556.1. Feet down the mountain. I know this chapter definitely hikes it up a bit with our trig and whatnot. So just a reminder, make sure you're asking for help as soon as you are possibly like getting stuck or lost. Happy to help, but if it does like kind of avalanche if it all once and you're like, wait, I didn't get tangent. How am I supposed to do sine and cosine? Also a reminder, make sure you please check out your Big Ideas Math textbook. There are lots and lots of example recordings in there and also some self-assessments for you to try problems on your own. You're not graded on those, so try as many as you would like. And that is it for this lesson. Let's say bye.
Bye.
Bye, everyone.
Yes. Put them in the video. Wait,
All right, last but not least, 9.6, we are going to solve these right triangles. This solve it squad, our learning target, find unknown side lengths and angle measures of right triangles. We're going to do some inverse trig ratios and inverse trig ratios to approximate angle measures, solving those triangles. Okay, let's go. So a reminder when we're labeling our triangle, again, that 90, the theta is your viewpoint. It's either the angle you know or the angle you want to know. The three angle measures, A, B, and C, side lengths, little a, b, little c. Across from that angle we know is that opposite side, adjacent side, and then our hypotenuse is always the side that is across from the right angle. We have SOHCAHTOA, sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. Super quick here because this is a bit of review. A reminder also that we used what was called SOHCAHTOA to remember this. So stands for sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. SOHCAHTOA. Trig tips. First thing you want to do, label your side lengths, hypotenuse opposite, then adjacent. Determine which trig ratio you're going to use based off of SOHCAHTOA. Write your equation down. Plug in and solve for the unknown. You're going to use your calculator. We're going to use Desmos always. If the unknown is on the top, the numerator, we can just cross multiply and solve. If the unknown is in the denominator, you're going to have to cross multiply, then divide to solve. It's a lot, right? Oh no, though. We have more. What if we want to find the angle measure, theta? So a little bit more this time. Let's take a look at a new type of trigonometry problem. Interestingly, these problems can't be solved with sine, cosine, and tangent. Oh no. The problem in the right triangle below, what is the measure of angle L? So previously, we've always had an angle measure. We had the 90, but we also had another angle measure. What if we don't know any angles though? What we know relative to angle L, we know the lengths of the opposite and the adjacent sides. So we can actually write, because this is angle L, this is our opposite side, this is our adjacent side. We can use tangent, we can write that down. Tangent of our angle is opposite over adjacent, 35 over 65. So our unknown here is actually this L, which is linked with the tan. So we can't just like divide by tan. We kind of can though. Okay, we're stuck. What we need a new mathematical tool to solve problems like these. Our old friends sine, cosine, and tangent just aren't up to the task. They take angles and give side ratios, but we need functions that take side ratios and give angles. We need what are called inverse trig functions, which we have. It's just more buttons on our calculator. All right, you ready? Ready. Misconception alert also, the expression sine -1x is not the same as 1 over sine x. Some of you that know real advanced mathematical things at -1 sometimes says flip a fraction. Not in this case. The -1 is not an exponent. Instead, it simply means the inverse function. It means to use that button on your calculator. All right, our inverse tangent will help you find an angle if we know the opposite and the adjacent. Inverse sine will help us find that angle if we know the opposite and the hypotenuse. And the inverse cosine will help us find that angle if we know the opposite, adjacent over hypotenuse. Sorry, goodness. SOHCAHTOA. You're going to use those same trig ratios that we learned. SOHCAHTOA, just a little bit different this time, and we'll get there when we do some examples. Determine which of the two acute angles has a sine of 12/13. Is it going to be the two acute angles, angle E or angle F? Think about this one for a second. Which angle is the sine 12/13? Okay, fine. Well, if we're looking at angle F, opposite, sine is opposite of our hypotenuse. Angle F would be 5/13 would be the sine. That's not it. Angle E, opposite of our hypotenuse, would be 12/13. It is the sine of angle E is 12/13. See, we're already getting there. Baby steps. All right, next up. Example 2. Try this one on your own. Let angle G be an acute angle and the tangent of angle G is 0.43. Use technology to approximate the measure of angle G to the nearest tenth of a degree. You're like, wait, what? What do I do here? All right, tangent of angle G equals 0.43. Well, we cannot just solve for angle G here. We got to get rid of that word tangent. To do that, we take the inverse of it. So tangent of angle G is going to be, angle G is going to end up being, and I'm going to show you the mathematical, like why this works. To get rid of that tan, we take the tan inverse. It's like inverse is like opposite. Tan inverse, we're going to multiply. Those go away. But what you do to one side, you must do to the other. So we need to take the tan inverse of that 0.43 also, and we'll get angle G. Okay, so really what that means here, angle G equals the tan inverse of 0.43 in your calculator. Okay, let's all find that calculator. We're going to use Desmos. Okay, so anytime you have the ratio of the sides, you just do inverse of it to find the angle. So, okay, Desmos. All right, how do we do inverse tan, you're asking? Okay, if you hit this function key right here, there they are. Sine inverse, cosinverse, and tan inverse. So the inverse tan. And then you go back to main, do 0.43. That's our angle, 23.27. How many decimals did we want? To the nearest tenth. So 23.3. 23.3. Angle G equals 23.3 degrees. Makes sense. It's a degree. It's an acute angle. If it was obtuse, it's not going to work. So make sure that you are double checking your answers to make sure they even make sense before moving on. All right, let's try another problem. Well, as I said in the beginning, I said we're going to solve triangles, so that's what we're going to do. To solve a right triangle means to find all the sides and all the angles. You can solve a triangle when you know either of the following: 2 side lengths, 1 side length, and the measure of 1 acute angle. Again, these are right triangles, so you actually already know that one of the angles is 90. But so yeah, those are things you need in order to solve a triangle. So guess what? Let's do some. All right, solve this triangle. Round decimal answers to the nearest tenth. First up, what do we do? Well, we want to find side length DE. So we're going to actually just use Pythagorean Theorem to find side DE because we know 2 sides. Let's find our third side. So a squared plus b squared equals c squared. Plug those in. 21 squared plus 21 squared will equal our c squared. 400 plus 441 equals c squared. So we have 841 equals our c squared. In order to solve for that c squared, we need to square root both sides, square root that 841, and we get 29. So 29 is our side DE. That's our hypotenuse. Okay, so then the other two, opposite and adjacent, they're just going to depend on, are we going to be using angle D or angle E? Because they do flip-flop depending on which one we're doing. So we have side DE. We now need some angles. Anytime we're wanting to find angles, we're probably going to have to use some inverse stuff. So be prepared for that. All right, next up. Since we know all three sides now, we can use sine, cosine, or tangent because we know all the sides to find the missing angles. I'm going to just use tangent just because right off the bat, we weren't given the hypotenuse. So I'm just going to use the original sides we were given, which is 20 and 21. And so those are opposite and adjacent, which would mean we'd use tangent. But you could use sine or cosine too. It doesn't really matter. And so setting that up, I know that the tangent of angle D, and I picked angle D, you could pick angle E, it would just flip-flop them. So the tangent of, but we're trying to find angle D here first. So the tangent of angle D is opposite over adjacent, so 21 over 20. In order to find that angle D, we'll put that in our calculator. Inverse tan of 21 over 20 gives us the measure of angle D. Screenshot of what I typed right in there to Desmos. Inverse tan of 21 over 20. We get 46.39. So about 46.4 degrees is the measure of angle D. We're almost there. I did not write that one in. I probably should. Let's go ahead and write this in for angle D, 46.4 degrees. Look at that. We have all three sides and we almost have all three angles. The only angle left is angle E. We can use trig again to find that, but it actually is the easiest if we just recognize the fact that the sum of the measures of the angles of the triangle are always 180. Now that we know two of these angles, we can find the third. And so we are just going to go ahead and do 180 minus 90 minus 46.4, and we get 43.6 for our angle E. And look at that. We solved our triangle. Super fun, right? All right, I want you to try one on your own. And I think we'll just do, oh, we'll see. I think we can do, got two more. We'll see how we do on this one. Solve the right triangle, round decimals to the nearest tenth. So first, just like before, we can just use that Pythagorean theorem in order to find our missing side length. Just note here that this side here is our hypotenuse. So that is my C. Okay, and so when we put that into Pythagorean theorem, I'm going to do 9 squared plus b squared, actually p squared, equals c squared, which is 25 squared. So then we've got 81 plus p squared equals 25 squared. Goodness, I'm gonna have to use Desmos for that, aren't I? I should have known. I think I know this one. D5 squared, 625. Where are we at? No. No. She's back. Hey, I'm recording, so please wait. You know, please don't. My daughter's back. Okay, 625, and then we're going to solve this. We're going to subtract 81 from both sides. Okay, we're subtracting that. And so then we have p squared equals 625 minus 81. That's 544. We're going to take that and just do the square root of it. Square root of 544. And 23.3 is our value for that p. So this is, and that makes sense. Again, double check your work here. Our hypotenuse is supposed to be our longest leg. Our hypotenuse is 25. If this length was more than that, then we would have known we didn't do that right because our hypotenuse needs to be that longest leg. Next up, pen. We are going to, so that's side QR, that's 23.3. So I'll go ahead and label this here. Okay, we're going to try to find angle P. And go, I think it would help more if I had it. Thank you. She is helpful. Okay. And so this one, we know all three sides now, so we can use sine, cosine, or tangent. It doesn't really matter. And so, I don't know. We're trying to find angle P here. I'm going to change to pink. And so I'm actually just going to use the 9 and the 25 because those are original angles that we were given. 23.3 is a rounded answer. So we really don't want to use that when we're trying to find another answer. So we know the hypotenuse, 9 is going to be our adjacent. So we're going to use the ratio of adjacent over hypotenuse. And if you need a recollection here, so TOA adjacent over hypotenuse is cosine. That's better. So we're going to say, okay, the cosine of our angle P is going to be the ratio of our adjacent side, which is 9, over our 25. Again, we're trying to find that angle here. So we do our inverse trig ratio. We're going to do the inverse trig of 9, inverse cos of 9 over 25. And that's going to give us angle P. So let's go ahead and plug that into our calculator. Inverse cos of 9 over 25. Okay, Desmos, inverse cos. Again, you hit that function key, you hit inverse cos, and then back to main, 9 over 25. And 68.9 degrees. I'll go ahead and write that here so that we have it. So maybe 68.9 degrees is going to equal angle P. Let's go back to our slides. Actually, I really like it when the screen's black and then these are bright colors. So angle P is 68.9 degrees. Let's go ahead and draw that in there. So 68.9 degrees. And then angle R, we could do more trig if we want to, or just use the fact that 180 minus 90 minus that 68.9 degrees is going to give us angle R. So 90 minus 68.9. Um, 21.1 degrees is our answer for that one. 21.1 degrees. And I'll go ahead and put that in there in my slide. I took it already. 21.1. Whoops. Hurrah. We gotta go back. Back slides, sorry. Where were we? There we are finally. Okay, there we go. Oh boy, 21.1. All right. Woo. All right. Guys want to do one more? Woo. One more solve. You can stick around for it if you're still struggling, but you don't have to. I'll just go ahead and do one more in the recording for you. The next one I don't think is inverse. Yeah, we have an angle, so we actually don't need to use inverse in this case. So my first thing I'm going to do is actually find angle Y, because we know that those three angles need to add up to 180, and so angle Y is going to be 38 degrees. because 90 minus 52, 38 degrees. And then from there, just depends what we want to deal with here. So angle Y is 38 degrees. Let's just use that angle X here, that 52 degrees, because that was what was given. According to that angle here, this is going to be my opposite side. This is my adjacent side, and this is my hypotenuse. XY, so XY, that's my hypotenuse. I'm going to call that side Z because it's across from angle Z. Let's find that one first. So in order to find that hypotenuse, we're going to use hypotenuse and adjacent. So SOHCAHTOA. Hypotenuse and adjacent is cosine. So we'll do the cosine of angle X equals adjacent, which is 8.5, over hypotenuse, which is Z. We're going to multiply both sides by Z. And then divide. So Z equals 8.5 divided by, cosine of angle X. We know that that's 52. I'm going to go ahead and go back and put that in there. Sorry, we knew that that was 52 from the get-go. And so 8.5 divided by cos 52 in our calculator. Which was an easy way to get to Desmos. Okay, 8.5 divided by cos 52, 13.8 is what my Z is going to be. So let's go ahead and go back to my slides. Makes sense when we go to the slides and see where I'm writing. So that side, that XY side is 13.8. This side, 13.8. And then let's go ahead and find that opposite. I'll just keep using that angle Z, the 52 degrees. So we're going to use opposite over adjacent in this case, since the 13.8 is rounded. Opposite over adjacent is tangent. So I'm going to go ahead and use the tangent of my angle X, which is 52 degrees, equals opposite, which we don't know. Actually, let's call that Y is it's this side. We'll call this side side X. Side X over adjacent, 8.5. This one's a nice one where we just multiply both sides by 8.5. Put that in your calculator. 8.5 times tangent 52. 8.5 times tangent 52, 10.9 is going to be my X. And that is our missing side, 10.9. We've solved that triangle. So the more practice, the better. Definitely we'll spend lots of time on these in class. This was just an intro to it. We're going to do lots more problems. Also, as you know, and we've been over this a lot, be sure you're checking out your textbook, Big Ideas Math. You're going to 9.6. You're watching those example recordings and doing some self-assessments on your own before moving on. And asking your teacher for help, also important. Okay, bye everyone. Thanks for your patience with me and my daughter.